Welcome back. In this session, we'll be learning SQL, starting with the basics in order to query data, and then extending that knowledge to more advanced aspects, including views, constraints, and the likes of transactions. So, what is SQL? Well, SQL stands for Structured Query Language. In its simplest usage, it can describe the columns and rows that you want from a database table. In this session, we'll be exploring the main components of SQL and completing working examples to understand each concept and its usage. So, what are the main components? Well, to start with, you have the data query language. This allows for getting data from a database and imposing order upon it. It includes things like the select statement, where you can detail the columns and maybe some functions that you want as part of that select query. You then have the from statement. Here you will describe the tables that you want that data from. So the select part is generally the columns, and the from statement will be the data tables that you want those particular columns from. Now, as part of that from statement, you can do various different joins. So you can join two or multiple tables together, and then select the various columns that you want from those tables. You can do things like a left join, so you can join the table on the left to the right, but maintain the table on the left and just take the aspects that can match from the one on the right. Or you can do a right join, which is the opposite of that. You can do a full out join, or if you're completing maybe some more numeric functions, you can do a cross join, which will basically take two tables and join them in all possibilities. So generally used in some sort of statistical analysis. So that's your select and from. From there, you will have your where clause. So it's here where you can start restricting the rows of data that you want. Then you have group by. So if you wanted to do some summaries grouping on a student ID or an employee ID or maybe order reference number, and then getting a sum of the total value of the items that were part of that order, you would potentially use a group by for that. So that gets your grouping. Having then comes in where you want to basically filter the results from your group by. You then will potentially want to order the results from this particular query. So that would be done by the order by, and you can order by several columns from your select statement or elements from the table in order to do that. You may also want to limit the number of results coming back. So you can use the limit command to basically give you, in essence, the top 10, top 3, top 50. So you have that capability as well. And this all forms part of the data query language. And here we've got an example of a potential query you could have. So we're selecting the columns we want. So we've got an ID and a total cost from the table of orders. We're grouping by ID, and then we're actually summing or returning the order IDs and total costs, where the sum of those of the order ID is less than 500. So you've got various elements here in order to restrict summarized data based on this data query language. So that's one concept or aspect of SQL. The next concept is the data manipulation language. So it's here that you've got the main statements, which are insert, update, and delete. These are used together with some of the above query language in order to insert, to update, and delete data. So here on the right, we've got an example of an insert command. So here you'll have insert into and the table name. You then declare the various columns, fields for that table, and then you have a values claim and then within here you would pass each of your various values to correspond to the appropriate column. So as well as being able to query and manipulate data, we also are able to have transactions. So here we've got the transaction control language. This deals with transactions within the database, and these are incredibly important in order to ensure the correct order for change. If you think of this in a sort of scenario perspective, it will literally ensure that all the actions are completed within a transaction, or they will fail and it will roll back. So think of it, you want to transfer money to a family friend. Your bank will need to deplete your account of, let's say, £100, and will need to put that £100 into your family friend's account. Now, what would happen if the subtraction from your account doesn't complete, but the increase in your family friend's account does? We'll now have an increase of £100 at the bank, which you obviously don't want. So in order to do this, you have a start or begin transaction. You'll then complete all of your manipulation. At the end of that, based on the fact that each one of those commands is successful, you can then commit, and that will commit all of the change at once. The way it's kind of worked, if you think of it logically, is it's almost like an in-memory change. Wait at that point, make sure everything's okay, and then fully commit that data. There are some more complex sort of ideas and details on this about seeing committed or uncommitted data potentially, but conceptually that is how it works. Now, if any of those transactions were to fail, you can then call something called a rollback, and it would basically undo everything that you did after the begin transaction. So you can do your begin transaction, deplete your account of £100, increase the family friends by then £100, and commit. And if any of those two transactions fail, you can then do a rollback to put everything back to how it was. So this is around the transaction control language. Next then, we want to look at the data definition language. So here there are two parts. We've got the target, which are things like the database, a table within the database, constraints on the particular tables within the database. You can then have views. Now, a view is almost a query that you would build on multiple tables. So it may be within an application somewhere you want to have a view of all of a customer's orders with the items and maybe the current stock holding. There'll be various different tables within the database you'll need to take those elements from. So instead of creating a query and baking that in, it may be that you want to create a view because you might want to put it on a screen somewhere and enable a user to update it. And you can create views, and then you can allow changes to those views, permissions, etc., in order to be able to manipulate that data as well. So views can be very, very useful. We've then got things like indexes. So we talked about constraints, you can then have indexes. So that would be something like your employee number, which would be a key, a primary key, used to identify a particular record in a database. Now, you can have primary keys where you don't allow duplicates, and you can have sort of secondary composite indexes on things like first name, last name, probably more last name than first name, to enable you to query that table. And because it's got an index, the underlying database engine will be able to pull those records back because they're potentially going to be stored together or in a way where it can be retrieved more efficiently. So when we're talking about data definition language, we're talking about the part of SQL that creates and alters and deletes database objects. And we're also, from a target perspective, then going to be looking at things like the operation. So we've got the target, which is the entity, the actual item we're talking about here. So we've got an index, we've got a table, we've got a database, but then we've got the operation that's created on that. So we've got things like create, so we can create a database or create a table. We've then got delete, also can be known as drop. So when you drop a table, you're basically deleting not just the data, but you're basically removing the whole table. It's basically a delete, complete delete of the table, as opposed to here where you're deleting data. It's about data manipulation. This is really about deleting the target, the actual table itself. You then have update, so you can update a table, which you might want to add a new column to a table, so that you can do that in an update. Again, a different kind of update to a data manipulation update, but it's an update. And then you can do a rename. So if you wanted to change a field name or something to that extent as well. So that's the data definition language. Next then, we've got operators, sorry. So operators are things like and, or not. So these are logical operators that can be used throughout the SQL language. You can have them in your where clause. So give me all employees where they have been there for more than 2 years and they're part of the IT department. So we're able to use those operators as part of querying, part of updating, inserting, deleting as well. We then have functions. So these functions are generally based on the data types. So we can have numeric functions, things around division, multiplying, or sum. So we're summing here. That's a numeric function. We might want to do an average. Again, that'll be a numeric function. So all of those functions are available within the SQL language. We then have string functions. So we might want to take a substring. We might want to take the first 3 letters of a department instead of the full name as part of our query. You might also then want to take the left or right number of characters. You might also then want to remove trailing spaces, which you'd use something like trim. You then have date time. So date time's used quite often within a SQL query in the sense that you might want to get the current date and time, which is you use now to get that. So it could be that you want to insert data into a database and you might be inserting customers like we've got here. There could be a field for created date, time, or create stamp. Now, if you were going to do that, then instead of passing the physical time in here, you can actually pass the function of now. So when it inserts, it will automatically replace that function with the current date and time. And then you've got nulls. So null is always seen as a special type, but it's sort of used to describe a field that is not populated. So if you've got a field for, let's say, an address, so address line 1, you've got populated. Address line 2, you don't have that populated and it's never been populated. It's a null. If you put a blank spaces in there, that's an empty string. So null is really a special kind of type. It's completely different to an empty string, and it's something you really want to avoid. And the reason you want to avoid it is if you use a field or a column, so if you're querying data, and there is the possibility for a null field to be populated in one of the rows that you're going to do some numeric function on, you can get skewed or unwanted results. So where possible, you want to avoid using nulls and use defaults. If you've got a cost of something, it should be 0. It shouldn't be null, because null is not the same as 0. So that's the functions from that perspective. And then we've got some examples here. So you might have a select statement where part of the select statement you're calling a substring to take a string. This is SQL intro. You want to take the first character and return 3 characters from there. So you've got a short title. So that, if that was part of a query, you're basically creating a column called short title, and that would be defaulted because it's not looking at a column in a database. It's a fixed string that will say SQL. Is null, and if you give this a table column, will return a boolean, and that will either be true or false. And then now, as we discussed before, if you were to call that within a statement somewhere, pull it as part of an insert, it will then convert to something similar to this, where you've got the full date and time. So these are the main elements that we will be covering in today's session. One thing I do want to mention is we do also have procedural SQL, so PL SQL. When you're looking at anything SQL wise, you will find mentions of PL SQL. So what is it? Well, it's procedural language. So it's procedural language as an extension to SQL. It uses the SQL language, but you can basically create functions within the database itself, and then you can call those functions and pass various parameters to them. Very similar to the functions you've got based on the data types, which are standard out the box available as part of SQL. Procedural SQL is allowing you to create your own functions, and they could be useful functions in order to extend some of the functionality that you've got on the standard data types, or it could be something around business logic. You might want to have a function that you call in order to get the next customer ID, and then you just call that function as part of the values that you put through. You would just call that function, and it will give the next ID and just populate that. Or it could be that you want something event driven, so you might create a function that you would attach to a table, and that's generally called a trigger. So you could say every time you insert into a table, you want the old value to be populated in an audit table with the user, date and time, etc. You can do that using PL SQL. What I would like to say is we're not going to be covering PL SQL as part of this session. I will look at potentially creating a later session going through and building on what we build during this session in order to show you how you would create a function or procedure and how you would call that, and also potentially table triggers as well. So we know what we're going to be covering on here. We're going to be using MySQL Workbench. So I'll add it to the video, the link. MySQL Workbench is completely free. You can then build a database using it, and we'll be doing that during this particular session so you can follow along. One thing to note is that SQL syntax is different with different database engines. So when I say different, it's mildly different. There might be a slightly different command for the current date and time. I think for Sybase, it's today, open bracket, close bracket. So you don't pass any parameters for that particular, and it will give you the current date and time. It might be different for the likes of Oracle, for instance, or Microsoft SQL Server, or whatever. So you've just got to bear in mind that although the SQL kind of syntax and what we're showing on screen, the concepts are all going to be the same. Every SQL language uses all of these, but there might be some slight differences in some of the functions and some of the different commands that you might use in order to do things like limit and some various bits and pieces there. So you just got to bear that in mind. So if you take a create table or a particular function for my SQL and basically port it and copy and paste it for Microsoft SQL Server, it may or may not work. So there might be some slight syntax differences. Other than that, though, we are going to be using MySQL, and we can follow along and do that, but it's just something to bear in mind. So let's now look at opening MySQL, and we'll start building a database, adding tables, creating indexes and constraints, and then we can start inserting data in it and doing some querying and transaction building as well. So here we've got the MySQL Workbench. We're going to create our database, so we can literally right click here, create schema, and then we've got a name we can give our database. So I'm going to call this live data. I can then hit apply, and every time you apply in MySQL Workbench, it gives you the syntax that you can actually use. So if you copied this syntax and just paste it into the query editor, it would actually run this command. But we're using the MySQL Workbench in order to do some of this legwork for us. But it's always incredibly transparent, and it will give you the details of what it's creating here. And if we're talking about the type of command here, this is a DDL. So this is a data definition language, which is around creating the target. So if I bring over the PowerPoint presentation that we had earlier, you can see for the DDL, we've got database, tables, constraints, etc. So we're going to start here in order to create our database and tables. Let's hit apply and finish. So we've got live data up here. We've got no tables, no views, no functions. It's completely empty. So we can right click here and we can go create table. Now we're going to be using some of the wizards to do this just because it's a little bit easier. But again, every time you go and hit apply, it's going to give you the syntax that it's using, this basically the SQL query that it's using in order to create that table in this instance. So what are we going to do for our live data? Well, I think what would be quite nice is if we create almost a customer and orders database, tables. So let's start with a customer. So we want our customers table. And the first field we're going to put in here is the customer ID. That we're going to have as a type of integer. There are various different data types here. The main ones being these top ones here. So we've got an integer, we've got a variable character, which is basically a variable of string length up to a maximum. So in the brackets, you would put the maximum string length, and it can be nothing to the maximum. You then got a decimal where you can give it the length of the decimal and then how many decimal points. So if you had 12,2, that would be up to 12 digits in total, with 2 of those digits assigned to the decimal point. You then have date and time, and then you've got blob for larger storage of data there as well. Further down, there are various different other types that can be used as well, but we're going to focus on just the core ones for this session. So we're going to have an integer. Now here are some abbreviations for various different terms. So PK is primary key. Primary key is the field that's going to identify a unique row. Whenever you're creating a table, ideally you really want to be creating a primary key, unless it's statistical data, in which case you don't need every record to be sort of unique or uniquely identified, then you don't really need to worry about it. But for any real relational database, you will always have a primary key for that table. And that primary key can be a combination of different fields, or it could be a single field. So here we've got the customer ID, that's going to be a primary key. Naturally, it's going to be not null, and we're happy with that. And these here, just to use our terminology from the presentation earlier, are all different types of constraints. So we've created a database, we're creating a table in that database, and we're looking at creating fields and the constraints against each of those fields. So after we've got the customer ID, we then want to have maybe a first name. We're going to say 45 characters is appropriate here. We're going to say, well, whenever we create a customer, we want to make sure that they do have a first name. So we don't want to allow nulls, which is blank field. We then want a last name. And because we're looking at orders, let's say we want to have a limit. So this is the limit on the maximum that they can have for their ordering. So here we're going to create a decimal, and for this we'll make it quite a large. So we're going to have 12,2. And again, last name, not null, and we're saying when we create a customer, we want to ensure that a limit is always set. So everything in here has to be populated. Goes back to what we were talking about before when we look at our data types and our null. We want to avoid using nulls where possible. So that's our table, or the basic table. We can now hit apply. This is now going to give us the syntax that we are going to be using in order to create that table. Again, it's still on the data definition language, and we're creating a table in live data. So we've got the database name dot table name, and then each of the field names, the types, and any constraints. So we ticked NN, which is not null. So we've got not null for all of these fields. And then we've got a primary key being specified here as one field, which is customer ID. Let's hit apply. Okay, so we've now got our customer table. What we can do, we can close this down, we can expand tables, and we can see this here. And then you can use select all rows. It's got a standard 1,000 row limit just on the view. You can change that if you wish, but for the sake of this demo, that's perfectly fine. And we've got nothing in here. It's showing null, 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 null here because we can interact with this to create our records. Let's do that now. So we're going to have customer 1. We're going to say that customer is Luke Saunders, and he has a limit of £1,500 or dollars. Then we have 2. We're going to go Dave Shop, and he's going to have a customer, a customer limit of 500. We're then going to create a third customer, Sarah Rise. Just going to have 2,500. Customer 4. Oh, there we go. Bob Rainey, and we're going to go 75 for that. Customer 5. And you can see this is quite easy to do, but as we're doing this, this isn't actually inserting into the database, and I'll show you this at the moment because this is the way that SQL Workbench works. So we go Ray rows, we'll say a limit of 450, and one last one. Let's do a John Doe, and we're going to go 150. So we've got that now. What I'd like to do is I'm going to requery this table. You can see we've still got nothing in here at the moment at all. So it's not committed these changes at all at the moment. They're just sort of in memory sat there. No one can query that until we hit apply. It's then going to show us the SQL statement in order to create these records. So we've got insert into, database, table name, the fields that you want to insert to, and then the values. We're going to hit apply, hit finish, and now, even if we go on this screen, just to make sure it's very, very clear, if we issue that command, we can see select all from that table, and now we've got all of our customers. Perfect. So we now have a fully fledged customer table. Now we want to create our orders table. So create orders. And for our orders table, what are we going to do? So let's create firstly an order ID. That's going to be an integer and it's a primary key and not null. Then for each order, we're going to have a purchase amount. And this is going to be a numeric or decimal. So we've got 12,2. Keep it in line with the same sort of format as our limit. And we want that not null because we're only going to create orders that have been purchased, not pending orders. So then we're going to have order date, and this is going to be of type date time. Tick that. Then lastly, each order is going to correspond to a customer. So we can say we've got a customer ID in here. We're going to say we don't want it to be null. So you have to have an order that correlates to an existing customer. But what we want to do now is we want to set a constraint known as a foreign key. Now we've talked about primary keys being the unique field for that table. So you wouldn't be able to have order 1 in here and then order 1 again. And the same that every one of these customers here has to be unique. And if we try to, let's just put a whole load of rubbish in here, but we're creating this. It's a valid record and we've got a 1 in here. If we go apply, it's going to give us a statement. Yeah, okay, apply. We're going to get an error. And we can see here, we've got a duplicate entry in here because we've got a primary key on customer ID. So I can just revert that. And in the same way, we want to have the reverse done here for customer ID. So that's known as a foreign key. So in SQL Workbench, you can select your column, and down the bottom here, you've got indexes, and then you've got foreign keys. So we're going to give this foreign key a name. So we can go FK for foreign key, underscore and then the field name, customer ID. And then the reference table, it's going to reference the customer table. We're in the orders table. We want to reference the customer table. We're going to tick the column that we're applying this foreign key to, because the foreign keys are a list of foreign keys on the table, even though we did just select the field. And we're going to say we want to set that on the customer ID. Okay, and I've made a mistake. If I go back to columns, we've got this set to varchar. We want that set to int because it has to be the same data type as that for the customer. And if we check the customers table, if I go to alter table, we can see the customer ID here is int. So let's go back here. We're going to go back to our foreign keys. We're going to select the foreign key, customer ID. So customer ID from the orders table references the customer ID from the customer table, and it's a foreign key called FK underscore customer ID. So we've set all that up. We still haven't created a table, which is why it's not listed here. It's kind of in memory at that point. We're now going to hit apply. Now we get something quite interesting. So we get a create table for orders. We've got an order ID, which is not null. Purchase amount, not null, and that's a decimal. Order date, which is date, not null as well. And then we've got customer ID, which is an integer, not null. And we've got a primary key on this table, which relates up here. And then we've got a constraint. So the constraint here is a foreign key to the customer ID field on the customers table. So we've got customer table, customer ID, and then we've got the foreign key constraint is on this field here. So if I hit apply, hit finish, we'll see it now appears up on here. So the table is fully created. We can then hit select all, and we're now in the same position we were with the customers table. So again, we're going to create some data here. So here we're going to create some orders. So order ID 1, we can go £155.89. Order date, we'll just grab a random date for this in this area. Let's just do that, just copy that. Customer ID 1, order 2. And if we pull up on here, what have we got? So if I grab that, move that over, close that. So I'm customer 1, 1500. So let's just make sure, again, we can put things in place to restrict purchases and things like that. In a later session, we can use triggers and PL SQL in order to do that. So let's go in and go to 150, same order date, that customer. And then we want order 3. We can go £400, and this is going to be for customer 2, which is Dave. 3, and there we go. So we've got Sarah Rise, who's 2,500. So let's go 1550 on and 50 pence. There we go, and that's going to be customer 3, and then customer 4, 75. Let's skip customer 4 out. So then we're going to have customer 5. And what is their limit on here? 450. So let's go jumping all over here, 375.99. And then order 6 we'll do for John Doe of 75.89. 6. There we go. So we've got all of that. We can then hit apply. In the same way we get our script, we can hit apply, hit finish, and then we can select all, and we can see that data there. So we have very quickly here created a live data database with both customer data and order data. What we're going to do now is we're going to open a blank query screen, and we've got a requirement to create a query to show customer details with orders. So what we're going to do is we're going to select all, so select star from customers, and we're going to do a left join orders in order to bring the order data back. Now what we do is we're selecting all the fields, we're going from our customer table, we're left joining, which means we're joining customers to orders. And we need to describe what field we're doing that on. So that's going to be on customers.customer ID. So we've got the customer ID here. That equals orders.customer ID. So let's give that a go and see what happens here. So we execute that and we get the result here. So because we've done a left join, it will always bring back all records for customers and then the associated orders with that particular customer. So we've got Luke twice because Luke has two different orders, order 1 for 155.89 and order 2 for 250. But we've also returned back Bob Rainey and his customer limit, but we have got Knowles here because he hasn't ordered anything from us. So this might not be what we want. We might actually want, well, we want the customer information attached to the orders that we have had. So in order to do that, you could very quickly here do a right join. And what you're saying is you want to join these tables, but you want to join customers to the orders. So the order is the main table here. So if we now execute this query, you'll see that we don't get the customer who was Ray. Oh, no, sorry, it's Bob Rainey. So we shouldn't see Bob Rainey here at all, and we don't, because he hasn't ordered anything. So this is an example of the difference between left and right joins. There are other joins as well. We mentioned before, if I bring the presentation back over, we've got things like cross join, full outer join, and then you've got inner joins and standard joins as well, which are pretty much the same thing. But that gives you an idea on how you would join that data. Now, something to be aware of when you're doing this is you've got all data coming back. We've put a star here. So actually, we've got two columns here that have got the same information in them. So we might actually want to start restricting this and go, well, we're really only interested in the name and the amount of those orders. In which case, you can restrict those fields. So we can go, actually, we're just interested in the, I'd say the order ID because it's about orders. We might say we just want the first name, last name, and the customer ID and the purchase amount. So we execute this. We've got an error. And I did this on purpose just to show. We've got an error here because we've got an ambiguous column. And what that means is we've got two tables with the same name. So we are joining two tables. And even though in this case these fields have got the same values for both of these because we're joining based on that, the database engine doesn't know which one you want. So you have to be aware that you really want to, in order to make sure that you're being very precise here, that you give the table that you want that column from. So it's table name dot column. Now if we do that and hit run again, we now get the required result. So it's something to bear in mind there. Now what we can also do is we can restrict. So we talked about where clause before on restricting data. So we can go give us all of the data for purchases with the customer name where the purchase amount is greater than 300. So we're now restricting the rows. So if I run that now, we now only get 3 rows. And we can say, and the purchase amount is less than 1,000. So you can have restricting there based on logic, ands, or etc. as well. So this again is covering our operators that can be used in there as well. As well as this, you can actually delete data. So if we've got this data on here, we might say, well, actually, the last customer or this particular order we want to delete. So we can right click here and we can hit delete. And then we can hit apply. And again, remember, when we've got this, we've got it set so that it's going to give us this prompt for review. And half of this is to ensure that we're executing what we want. It's kind of a sort of a bit of a fail-safe, but it also gives us a good view on what's happening behind the scenes. So we're deleting from livedata.orders, because it's the orders table within the live data database, where the order ID equals 6. And then if we hit apply, that's been successfully applied and it will be gone now. And it also means if we then start doing a query that gets those results, that would be omitted because it's deleted that particular row. So we've covered selects, including joins and wheres. What we haven't covered yet is group by and where you might want to use that. So you might have a requirement to query the list of customers and their total spend. So if you want to do that, you can use the same query we've got here. We can go, well, actually, we're not worried about order ID in this case. We want the first name and last name. We want the customer ID, but the customer ID is going to be from the customer table. It's not going to be per order, or well, actually, no, it doesn't matter. We can do this. So let's do that. We'll keep orders in here. We want the total that they've spent, so we're going to use sum. So we're now looking at functions. Now, if we do this, we're just going to get a named column here that says sum and in brackets. So you can use the as to give it a name. So we can call this total spend. We can get rid of this where clause for the time being. So let's run this at the moment and you'll notice that it will fail. So it's failed because we're summing and we haven't given it a group by. So we want to now group by the customer. So if we group by the customer and then execute this, we now get our total spend here. And we can check this very quickly. So if we have a look, Luke Saunders is £405.89. So if we look at Luke's orders, Luke is customer ID 1. We've got two orders here, so 250, 350, £405.89. So there we go. So we know this works, but it's just going through that process. So we're able to do our group by then. Now, it might be that, yeah, this looks all right, but we don't really need the customer ID. Well, then we can take the customer ID out. And what we could possibly do as well is we can use a string function. So we can use something called concat. So as you type for functions, it will give you suggestions. So you've got a bit of IntelliSense on here. And we'll say we want first name concatenated with an empty string, followed by last name. And we can then take this out, keep the column in. And again, because it's a function, we want to give the result a column heading, a little bit like we did with total spend here. So this could be customer. So let's execute this, and we should still get the 4 rows there. There we go. And that looks a lot nicer than what we were getting previously. So again, that's a use of group by. Now, what you can do from here is we looked at doing a where clause earlier. So if I just copy this, so if I go back to what we had in our previous exercise where we had a where clause is used to restrict the data coming from the tables. What we're looking at now is a having clause, is what restricts based on the results from the group. So we can say we want to only return customers whose total spend. So again, we're going to pinch this up here, is greater than 400. And if we execute that, we get our 2 results. So that gives a good use on our select from, group by, wheres and havings. If I remove this having clause and I re-execute, we're going to have our 4 rows back. Now we can turn around and it could be that we're asking who the top spender is in our total spend. So what we'd need to do in order to do that is we've got a way of getting the first. We've got something called limit, which if I bring on screen for our getting to know SQL, we've got limit here. This limits the results. So if we go limit 1, it will take the top result. But by top, it means the literal top. So if we run this, it's saying that Luke Saunders is the top spender. But if we look at it, it's not. It's actually Sarah Rice. So what we need to do is we need to now order, which is used by order by, and we need to order by the sum of the purchase amount. So if we do that and run this, we now get low to high, but we want it high to low. So if we do it in descending order, because an order by will always be ascending by default, we now have Sarah Rise at the top. So now when we introduce a limit, who's the top spender? It's Sarah. Who are the top 2 spenders? It's Sarah and Luke. So what we've been able to do here is we've been able to cover the data query language. We've covered here the data manipulation language. We haven't covered updates, but I'll do that shortly just to show you how that works. And then we're going to have a look quickly at how we deal with transactions. So let's firstly look at an update. So we've got these details here, and for this particular order for £400, actually we made a mistake and it really should be £415.26. We can go on here and we can just edit that interactively. And then if we hit apply, we can see what update looks like. So it is very straightforward. So we're updating the database table of orders and we're setting the purchase amount to £415.26 for order ID number 3. So if we hit apply to that, it's as simple as that. So there we go, we've got an update there. Let's see if that makes a difference. Oh, and now when we run our query for the top 2 spenders, Luke drops out of that totally, and we've got Dave Shop as being the second top spender. Now let's look at transactions. So what would happen if we wanted to do a correction where for order 1 we want to change this to 150 and the £5.89, we had a system problem. So the £5.89 we actually need to increase on order number 2. We can go in here and we could separately do that. But if we do it separately, there is a chance that this transaction, if there was a table lock or something along those lines, doesn't actually work. And then we just increase this one. And then in essence, we've basically pushed £5.89 extra into the kind of system. We've kind of partially done the transaction. So how do we deal with that situation? If we open another tab here, what we do is we issue a start transaction. So if we go start transaction, and the way the SQL Workbench works is you can execute this for a particular statement, or you can execute this and it will do the whole lot. So we're just going to do this separately. So what we're going to do is we're going to say we want to start a transaction, and what we're going to do is, I'll tell you what, let's update the date, for instance. So what we can do is we can go update order, what's the data? It's live data, order, orders, set. No, let's do what we were going to do. So it's order 1, isn't it? So set the purchase amount of order 1, set purchase amount equal to £150 exactly, where order ID equals 1. And then what we want to do, I'm going to cheat a little bit. Let's just copy this a second. We want to then set the second one to 255.89. So 259.89. And we need to make sure that's order 2. And then we would want to do, after that, assuming you would check the results of these are both okay, and then you can do a commit, which would commit that to the database. Or if you had an issue, you could do a rollback. Now, I've got auto commit on, I think by default here. So let's do a test and see what happens. So we're going to run start transaction. So that's successful down the bottom. We're going to apply our first update. So if I check now in the orders table, re-query this, the top one should now change to 150. Oh, it has. We then want to do our second one. So if I do that now, that increases. And assuming that's okay, that's cool, we can commit that. If it wasn't, we can call what is known as a rollback. So this is now in essence there, but if I call rollback, this is now reverted back to 155.89 and 250. So this is where transactions are really, really useful. I gave the example around banking, and I think it's that's a very good example where we're depleting money from one account and pulling it into another. You need to make sure that that whole transaction is completed in one, and that would be done in a very similar way as we've just done here using a transaction. I think this is a good point to stop here. If I bring over what we've covered the data query language, so selects, froms, where, group by, having, order by, etc. We've gone over insert, update, and deletion of records using the data manipulation language. We've covered transactions, functions around summing, and we did some string manipulation there as well. We covered some of the operators, and then we also covered at the start the data definition language. We created a database, tables, constraints, indexes. We didn't cover views, and this is something I will cover as part of the PL SQL. I like to keep these sessions under an hour if I can. I think otherwise it becomes a bit too long. And then we also then covered creation of tables, updates. We didn't cover rename, but it's very, very similar in that sense. What we didn't cover is drop. So we've come to the end of the session. So let's have a look at the destructive power of drop. So as well as being able to delete records, very simply, we can just right click on our record here and then delete the row and then hit apply, etc. Just revert that. What we can also do is we can drop the table. Now, dropping the table is deleting the table. So it deletes the table, it deletes the data, and it is incredibly powerful and incredibly dangerous. So we're going to hit drop table here. You'll always get a confirmation here, generally speaking, unless you turn off all of the handcuffs, in which case, good on you, good luck, you will end up breaking something. If we then go review SQL, you can see here it's a very simple command. It's literally drop table. And if you execute that, which we're going to do now, that will instantly delete the table. The table's gone. There are no records, there's nothing there, and you're going to get an error saying the table doesn't exist. So that covers pretty much everything on this particular session. Thank you again for joining me this session. I hope you enjoyed it. I will be looking to put together some further SQL videos, including focusing on procedural SQL, PL SQL, and I'll look to also include some elements there around triggers and views as well. If you have any questions or if there are any topics you want me to cover, please feel free to reach out on LinkedIn or comment on the video. Thank you very much.